Mongeau. I'm Halogen and Toast on both Twitter and GitHub. And if you ever feel like contacting me, you can hit me up at goose@thoughtbot.com. If my email didn't give it away, I'm from Thoughtbot. We're a web consultancy.
I love you guys.
Thank you. We're a web consultancy not only in Boston now, but all across the United States. And we even have an office in Stockholm. But enough about that. My talk is about the art of Ruby. And at first, I'm going to make a few confessions. I'm not really a funny person, so if you don't laugh, that's okay. I wear a cool jacket instead. In addition to that, I'm under-caffeinated, and I have 102 slides. So here we go. So Donald Knuth said, a programmer who subconsciously views himself as an artist will enjoy what he does and do it better. And it is pronounced Knuth. I had to look this up. He has a fact on his page that tells you how to pronounce his name. So to get started, let's actually talk about what is art. And I grabbed this definition. It's a bit long, so I cut out the parts I didn't care about. And art is the expression or application of human creative skill and imagination to be appreciated primarily for beauty or emotional power. And that really speaks to me as a programmer. And in fact, it should speak to all of you. If you haven't thought of yourself as an artist before, start thinking of yourself like that. I've heard the term craftsman getting thrown around a lot. That's a great term, but I think artist is better. We're all artists in our craft. Well, let's drive the point home. What is art? To me, art is beautiful, it's creative, and it's expressive. What is programming? Well, I think programming is the art of writing code. And to me, code is art because code is beautiful, it's creative, and it's expressive. So now this brings us to the question, how do we write beautiful code? What do we need to do? And I find that when I look at code and I think that it is beautiful, I admire its simplicity. I love simple code. I love code that I can immediately look at and understand what's going on. Code should be clear. So let's take a look at an example real quick. This is for a guessing game. And to me, this isn't really that clear. It's got a lot going on. This method is really long. It takes quite a bit of time to parse. But having written this, I know that I'm really trying to accomplish three things here. I'm displaying some kind of a greeting, I'm playing the game, and then I'm displaying the status of what happens at the end of the game. So what if we change this a bit? What if we use the extract method pattern and bring it to this? Is this more clear? Is this more concise? I spend less time parsing this to try to understand what's going on. I know that we're printing a message, we're playing some rounds, and we're printing some results. However, this is still not good to me because we have this problem with context here. And we can actually fix the context problem by using the single level of abstraction principle. So I've actually pulled out that puts message into its own method so that when looking at this, you don't have a context switch. You can easily parse this as English, and it becomes quite clear what's going on and what the intent is. So I love using these principles in order to clean up code and make them better. And what they're really aiming to solve is fixing complexity. Right? To fix complexity, you're always trying to find balance. So let's take a look at one of those methods that I pulled out and see if we can find a better balance with it. So this is the play rounds method that I pulled out. And you can see that it's still quite a bit long to me. And I feel like I could make this a little bit better. Whenever I have a method that deals with iterating over a bunch of things, I often pull out the single thing into its own method. So here where I'm calling play rounds, I'll often pull that out into a play round method. So I have play rounds and play round. And I feel like this cleans it up a bit, but I'm being a little bit tricky here with how Ruby works. What's going to happen is puts returns nil, and nil is falsy. So I'm setting 1 equal to the number of times, and detect will actually cancel out as soon as it finds a true value. So if it keeps returning nil, it'll keep playing rounds until the true is hit, or we run out of times. So I don't really like that I'm being tricky here, but we'll come back to this. So I find art works best when you have constraints. And Igor Stravinsky, a famous composer, said that the more constraints one imposes, the more one frees oneself. And I really love this. I'm an origamist as well as a programmer. So in origami, I have a lot of constraints. I have a square sheet of paper. I can't cut it. I can't use an additional sheet of paper. I have to take that single small component and turn it into something beautiful. So I feel when you impose constraints as a programmer, you're trying to do the same thing. You're trying to find the beauty in that. So let's talk about code constraints. And this is a little bit of introspection into myself and the code constraints that I use. So this is not much of a surprise. I like 5-line methods. And this, of course, comes from Sandy Metz mentioning her rules. Additionally, I like 100-line classes. And lastly, and this is my own, I don't like classes in my public methods. And so what I mean by this is I don't like constants in my public methods. I prefer pulling those down into private methods where you can start looking at how things are supposed to work. So let's take a look at our constraints and how they applied to what we had here originally. So with this code, right, this was breaking the 5-line method rule, and I wanted to clean it up. And when we used extract method and the single level of abstraction principle, we got it down to this. This fits all of those rules, and to me, this is beautiful code. And then we had the play rounds, and we did the same thing, and I got each method down to 5 lines. So that was good. I felt good about that. But this is still bothering me. And again, we'll come back to it. We're going to fix that. Let's talk about breaking the rules. So Pablo Picasso said, "Learn the rules like a pro so you can break them like an artist." All right, so I mentioned that I didn't like this, and the reason why I don't like this is because I feel like the two different paths this if can take are very diverse. One is printing out a message, and I'm just banking on the fact that puts returns nil for this to work. And then the other one returns true. So they feel very separate from each other, and I'd like it if they were more balanced. So I could do something like this. I could say puts correct and puts wrong and have each of the corresponding parts return true or false. But then I don't have 5 lines. And this also feels very weird to me. Now, again, I can use extract method to kind of pull out those parts, right? And this is getting better. Most of finding your art is going through an iterative process. It's taking it from the unrefined part and keep distilling it until you get to where you want to be. Now, with here, I pulled out these methods, and I'm starting to notice a pattern. Can anybody guess what that pattern is? I'm talking about this concept of a guess in a bunch of different places, and not only here, in other parts of this guessing game. So what if I used the extract class pattern and pulled out a guess model? The guess model has a small public interface. They're all 5 lines. It's pretty expressive to what it does. And if I use this, that allows me to change my original play round code to this. It's much smaller and much more concise. I understand that when I'm playing around, I'm creating a new guess, I'm displaying the status of the guess, and then I'm returning whether the guess is correct or not. So by pulling this out into different layers of abstraction, I'm able to be more expressive with my code. So just to go over those again, when you have a lot of code, you use the extract method pattern. That's step 1. When you have too many methods and you start noticing patterns, you then move on to extract class. What happens when you have too many classes? Well, then you extract a gem or an app. So you start to notice patterns in your classes, and perhaps they can be reusable. You can pull them out. Or if your application's too big, maybe you really have 2 applications. What happens when you have too many gems and too many applications? You win. It's much easier to manage smaller components that are independent of each other than it is to manage one monolithic component that in itself is really hard to manage. Now, I feel like this is the white elephant in the room. It was the one question I got asked when I made a similar talk to this. What about performance? So John Carmack said, if you're willing to restrict the flexibility of your approach, you can almost always do something better. And I feel like this is true. So I'm going to give you an example. I'm the maintainer of a gem called Alchemist, which its intent is to convert units from one measurement to another. So meters to kilometers, feet to inches, different things along the lines of that. And I got this really strange issue in my GitHub issues that someone posted that when they were trying to parse a CSV, it was taking a ton of time. And this was without even using Alchemist. This is just with Alchemist loaded. And so they provided me this small case where if you just called time parse without Alchemist, it took 3.73 seconds. But if you called time.parse with Alchemist, it took 43.32 seconds. That is an enormous difference in time, especially when Alchemist is not even being used in the later example. So what's happening here? So I went to investigating, and I did some crazy Ruby code where I took an unbound method and rebound it. But what I wanted to do was print out what method was being called via method missing to see what was happening. And what I found out was that toString, toStr, not even 2s, toStr is called by time.parse, and numeric does not implement that method. Now, I actually haven't looked into the reason why Ruby does this. This seems completely out there to me, that they would call a method that doesn't exist as part of time.parse, but it does. Now, why is this a problem for me? Well, Alchemist has a syntax that looks something like 1.meters.2.feet. I wrote this a long time ago, and I thought that was a good idea. So what it ends up doing is it ends up having its own implementation of method missing, and it includes that into numeric. Now, this is the part we really care about up at the top here, is this parse prefix. And the reason we care about this is because right here, let's get rid of the stuff we don't care about, and furthermore, we just care about this prefix matcher. So again, I had to go down through these parts to find this. This prefix matcher creates a giant regular expression. It does this by mapping over all of the unit names and putting them together because I needed to see if the units also match prefixes, like kilogram or kilometer. So let's take a look at all the different parts of that. These are all the different prefixes. And this is the giant regular expression it was creating. So for every single method missing call it was making, it had to generate this regular expression and then evaluate against it. And so this is what was taking all that time. So here's a famous quote. Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems. I thought, I know, I'll use regular expressions. I now had two problems. But I didn't decide to get rid of the regular expression. And that was mistake number one. Instead, I decided I was going to memoize it. And this actually didn't give me that much of a benefit, a small amount. So the next thing I thought was that I would go ahead and escape out of my method missing early if it matched certain method names. And I don't actually have the code for that because I didn't keep that around. The reason I didn't keep this around was because I didn't feel like it was that great of an idea, as I'm just choosing which method names to escape from, so that meant I had to maintain this list, and what happened if someone made a pull request that said, oh, this other method, I'd have to keep updating that. Overall, though, I saw a benefit in the time. You can see that I went from 3.54 is the base. When Alchemist was loaded, it was 4.27. So that's a 10% increase on Ruby 2.0. On Ruby 1.9, I didn't see as much of an increase. But I decided to force myself to try and get this to where Alchemist didn't cause any time increase. And to do that, I decided to implement some constraints. And the constraints I decided to implement were that I wanted to keep my existing interface because people were using this gem and they expected it to work the way that it was supposed to work. I wanted to get rid of method missing. It was obviously a pain point, and it's one of my least favorite parts about Ruby. And then I wanted to, of course, increase the performance. I wanted it to meet or beat what you would have if you didn't have Alchemist loaded. So I set out to do this, and I refactored a bunch based on these rules. And so I got this idea here that I would load modules upon request. So you'd actually have to load the module in. And so this is just basically some of the code that's doing that. I kept it clean. And then I wrote this. This is the ugly part of Alchemist. And this is the public interface for it. And this was the private interface for it. So not that great, but it was definitely an improvement in performance. And I'm still following all of my rules. The only thing I'm not following here was that I'm using classes in my public interface. You can see that I have the word module there. And so I like having this as a red flag because it tells me that I'm being too obscure with what I'm doing, that I can actually do this a better way. So I set out to make this more easily parsable, and I turned it into this, which I feel is much easier to read. hopefully now everyone can tell what's going on. I'm building a module, I'm defining an expect method on it, and then I'm defining unit methods. So after making this change, these were the differences. Whenever you don't have Alchemist, it was 3.5 seconds. When Alchemist was loaded but not used, it was 3.5 seconds. And when Alchemist was actually loaded and set up correctly, it still took the same amount of time. Huge success. I couldn't bring myself to put a meme image in my slideshow. So this was my compromise. So what do you do if that's not fast enough? If you really, really care about performance, well, then you stop using Ruby and you drop down to the C level. No one's probably going to agree with me in this room, but I think it's a great way of really getting the performance you want out of Ruby and hiding the ugly bits to where people won't ever see them, because no one's ever going to look at your C code. This is guaranteed. I also drew that boat this morning. All right, so how can you be an artist? What do we have to do? The first thing you need to do is to have a toolbox. You should know what you want to do. So for me, my toolbox is my list of constraints that I apply to myself every single time that I write code in order to decide how I'm going to make something better. And not only that, it's the tools that you use, and I'll cover a couple of those in just a second. Additionally, you need to be inspired by others. I think that's really important. We talked a lot about pair programming during this conference, and that is a great way to get inspired by others because you get unique points in perspective that aren't yours. An easy way to be inspired by others is to surround yourself with talented artists, and I work at Thoughtbot, so I have an advantage that I get to be surrounded by tons of artists every single day. If you are working by yourself and you aren't, I mean, everyone here I assume is part of the community and talking to other people, but if you're alone, you should be going to meetups and you should be talking to other people and getting new perspectives into the ways of doing things. You should use well-known techniques. Nothing that I really described here today is something new, right? We're artists. We're stealing from other people all the time. There are tons of good books that talk about how to write good code, and you should read them. Another thing you should do is you should measure your improvement. I use Code Climate as a good indicator. It's not perfect because there's ways to game the system, but it's a good way to take things like Alchemist, which I wrote a long, long time ago, where I had Fs, and I used the techniques that I knew, and you can see I immediately went from an F to an A. I actually brought the whole project up to an A just by following those methods and those patterns. Another cool tool you can use is pull review. Pull review gives you a bit more introspection into different things that you're not going to get from Code Climate, such as I'm missing documentation in a ton of places. And that tells me I'm writing a gem. There should be documentation. But this gives you good information about what you can do to improve your code. I think another important thing that people forget is you should have feelings. Code should make you sad. Code should make you angry. Code should make you happy. I always say that when I'm writing code, if I feel happy, that's great. If I feel like I'm being really sneaky, that's bad. So I try to avoid being really sneaky in my code. I want to make sure that other people are going to understand it. Especially if you're a gem writer, you want other people to understand it so that they can contribute. You need to know when to break the rules. This is really important. So in my previous example, I had to decide when I had the true-false being returned if it was worth breaking the rules and having an 8-line method. And I decided it wasn't, that I could go further. I forced myself to try and figure out if that was the appropriate time to break the rules. And sometimes there are. If you're working with other developers, it's really easy to tell if you're allowed to break the rules because you ask them. You say, is it all right that this is a 6-line method? And they can look at it and decide with you. Just because 5 lines is a good metric, it doesn't mean it's perfect. You will never get away only writing 5-line methods. You sometimes have if, else, else. And that's going to be more than 5 lines right there. So you have to ask yourself the right questions and decide, is it okay to break the rules? And the single most important thing that you should do as an artist when writing code is you should have fun. Everyone should remember that we are programmers because we love it. It's something that we do that is exciting. And if you're not having fun, maybe you need to walk away for a little bit and come back when you're ready to have fun. All right, so that's the actual end of my talk. I want to mention that I am part of Thoughtbot's Learn Prime. I teach workshops. And if you're interested in finding out what we have to offer, you can go to learn.thoughtbot.com/prime. Additionally, I'm going to be one of the instructors at METIS. And METIS is a 12-week boot camp similar to Dev Boot Camp, General Assembly, those types of things, given by Thoughtbot and Kaplan. We're a joint effort, and we hope to do something really special here. So if you want to find out more, you can go to thisismetis.com. Questions? Yes? That's true. But I think getting angry at it is a good thing because it makes you want to change it. It makes you want to fix it. I look at code that I wrote years ago and I get angry at it. I'm like, what was I thinking? The Alchemist gem actually had a giant hash of all the unit names. That's part of the reason why I had an F, was because I had this 80-line plus hash of mappings of all the unit names to the conversion values. And so the easy way to make CodeClimate not care about that was to put it into a YAML file. Because it doesn't grade YAML files. But it was actually a better structure for it. It's data, it wasn't code. And I was sticking it in there and pretending like it was code. So I think the fact that I was angry about it, that it was always in there, and I pulled it out into a better structure for it was a good thing. So yeah, I think getting angry is a great response. Yes?
You spoke briefly about documentation. And if you look at something like code, it speaks of code as documentation, but what is your opinion on that? Or how do you feel about documentation? What do you personally do, for example, help with?
Sure. I think there's really two different perspectives to this. We'll talk about gems in just a second, but ignoring gems, I think comments are evil. You should be writing code that documents itself, like you were saying. It should be understandable. Someone should be able to look at it and immediately understand. I think this almost goes back to the Lisp days, where you were always doing layers of abstractions until the point in which it read like English, it made sense. Ruby is all about that. In case you hadn't noticed, if you do layers of abstractions, which are really easy to do, code becomes self-documenting. Gems are a bit different, and the reason why gems are a bit different is because a lot of times people aren't looking at the code. They don't care about the code. They just want to know how to use your gem, and so you need to document. You need to say, this method does this and returns these types of things, because they just want to use it really quickly, throw it into their project. So I think in gems, it's more important to document in a format that can be turned into something like RDoc or other types of documentation. Anybody else? Yes?
When you're doing a basic Rails app, for example, you start off with the app, you follow all the normal, like, where you start at things with the blog post, for example, you really immediately create a model, and now you've already got your class, persistence, and all these difficult things to change, and then you actually just start building the logic around that. And I think that, I feel that's very constraining. So how would you approach that, sort of avoiding that, locking yourself down to your class name before you've got any logic?
I think that's hard. I think it's okay to make mistakes early on. Being locked down to a class name I don't feel is terrible, because whenever you're choosing a class name, it's part of your domain, right? You've designed the application. Part of it is if you didn't spend enough time designing your application ahead of time before you start coding, that's a fallacy. You should plan out your entire project. I'll often just draw out my schema and draw little pages above the schema to represent where I think those components work on pen and paper. And so I don't feel like I'm locked into anything at that point. Once I've kind of designed out what I consider the MVP, I know where I want to go. And additionally, with greenfield projects, those are the best places to actually apply these rules. We at Thoughtbot decided to do an experiment where we worked on a client project, and we only used Sandy Metz's rules to the T. And it worked out swimmingly. You would think it'd be really difficult, but it wasn't. It was really great because we had 3 developers. We could choose when to break the rules. And it was maybe a little rough for about the first week, but every week after that was much easier to work on the project than any other project I'd ever worked on before. Anybody else? Cool. So if you want to talk about the art of Ruby with me, or education, or anything else in terms of programming, I'm Goose, and I'd love to chat. Thank you.
No come electro por la vida.